Okay, so for today's lab, we're going to look at a skater park. So when you follow the link from the website on Canvas, you're going to click here on Playground, and we're going to build ourselves a skater track. So we're going to grab the track here. We're going to make the left side as far up and over as we can. We're going to make the right side as far over here as we can without getting behind the menus there. And we're going to make this go as low as we can, and that's going to give us a nice little track. We're going to start with a mass that is small, so this skater is 50 kilograms. We are going to have no friction today. We're going to see what happens when there's no friction. I'm going to add a grid right here so I can see how high the guy is, and I'm going to include a speedometer, which will measure the speed of the skater. So to start, I'm going to put this on pause, and I'm going to take my skater, and I'm going to put him right here on 6 meters. So you got to be really careful that that red dot right there is exactly at 6 meters high. And then the speed, of course, right now is 0. So what we're going to do is we're going to find the kinetic energy and the potential energy of the skater right here at 6 meters. So as you know, the potential energy is mgh. So you'll take m, the mass, which is 50, times g, which is 10, times h, which is 6. So 50 times 10 times 6 is 3,000. He has 3,000 joules of potential energy, and he's not moving, so he has no kinetic energy. Then what you can do is you can hit play, and you can watch him zoom back and forth. And you'll notice when he gets to the bottom, his speed is fast, and when he gets near the top, his speed slows down. So what we want to do is we want to stop him right here at 5 meters. So down here, there's a slow motion button, which when you push it, slows him down, just makes the movie slow motion. And I want to stop him right here near near the 5. So I'm going to push pause, and then he's not quite on the 5. I'm going to carefully advance this with this button right here until I can see that he is just, that little red dot there is exactly at 5 meters. And so now, I know how high he is. He's at 5 meters above the ground, and so I can find his potential energy, mgh. And he's also moving. So I froze it, but he was moving at that point, and so I've got to find his velocity. So his velocity looks like 1 meter per second. Here's 2 meters per second. Here's 3. Here's 4. Somewhere between 4 and 5, and not quite halfway. So I would say more like 4.4 meters per second is his velocity. And if you know his velocity, you can find his kinetic energy. And so what you're going to do in the lab table is you're going to fill out his height and his velocity, and then calculate his kinetic and potential energy and his total energy for a bunch of different places. So you'll let him go again, and it's okay if you miss. We're trying to do 4 next, but if you miss it, you can try to stop him over here on this side at 4. And if you get close, that looks like it's on 4 right now. So this line right here is 4 meters. Read the speed, find his kinetic and potential energy, and then go to 3 meters, which is about there. And then you can go to 2 meters. And if you miss it, like that red dot isn't quite on 2, you can just keep going and try to stop him on the other side. And try to, as carefully as you can, get him right on 2 meters, and then 1 meter, and then all the way at the bottom. Okay? Record your data, and that's our e-learning assignment.